What's going on, guys? Today we're working on Cfast 2.0 card. Those of you who know what those devices are, they're basically SSDs in a compact form so that they can fit inside of the cameras. Usually used for production of video and stuff like that because they're much faster than traditional memory cards like SD and other types, but they are extremely expensive. So it's something that is specialized most of the time for cameras that shoot high production video. I was pleasantly surprised to find out that Angelbird had implemented a silicone motion controller on this device, and from what I gather, it should be supported. Now, Angelbird CF Express Type A cards that I've seen before, they come in with their own controllers, they come in with their own memory chips branded, so I wasn't even sure if there is any potential option for recovery of this device. When I saw it, I was like, maybe we've got a chance here. In this video today, you guys will see the entire process. Hopefully you like this episode. Let me know what you think in the comments below. Enjoy the show. I also want to mention that the Patreon is finally up. I got a couple of episodes on there for now, but this is something that's going to be routine. I will be posting one video per week on Patreon. Thank you for the support, and I would be super glad to see you all there. Today we're working on this Cfast 2.0 card made by Angelbird. Some work has been already done on it. Chips had been removed. This is a controller that's supposed to be on a support list. Now, this device being an Angelbird device, there could be obviously some hidden obstacles that our tools would not be able to handle. But in order to rule those out, I gotta make sure that the connection is 100% solid. What doubts the connectivity right now is the fact that this chip is not sitting perfectly balanced. It's seeing strange number of banks. We got two memory chips, 1 and 2 on the back side, but when I connect this device to an adapter, this is what we get. So pay attention to this part here, because this is where we can force safe mode for the device. These two connections right here currently are bridged. You see there's a little tiny piece of wire in there. Slide it in. If I grab a cable and set it right here, plug it into port 0 on PC3000. Here's what happens. Fire up. We get ready status. It's consuming 90 milliamps, which is all good. When we go into NAND flash chips, up here, there is a memory chip test, but the channel number 3 here shows nothing in it. First things first, I'm gonna remove both chips. Absolutely dead. Well, they're not going to be absolutely dead because we do get ID from the utility in this case, but what I want to make sure is that we get a number of IDs that will correspond to what we're looking for. Line that up with the pin 1. This goes into adapter. And here we got all of them. That's the problem right there, guys, is that we need to have 8 banks. Alright, we have this stencil specifically for this device right here. Testing the board with the controller connected. We got a ready status and ID comes up. Good. And now we just need to plug it in and test it. Construction of the translator is going to be put on fast forward for you. Basically, this time consuming task can be anywhere from a few minutes to hours. I've had some cases run for days. And this is the task. So if we start reading this, it starts pretty active, but then it starts to develop ECC errors. We see that we have exFAT partition, which is something that gave me a lot of hope right at the start. And if we use bitmap to highlight only used sectors from this device, inconsistencies in reading do not negatively affect use space parameters. They will increase the use space if they're not read properly, but they will not decrease it. So there is no risk for us to underestimate the amount of data on the device if it's reading with errors. So whatever the number that it's going to say that is used is going to be more than what actually has been used. So right now it says 66 gigabytes, and this is a 256 gigabyte device. So that's reduces the workload for us drastically. All right, guys, this is something I just noticed that needed a little bit of clarification. So when we're building a map of used sectors from bitmap, bitmap file needs to be read. If we can't read the bitmap file completely, if it has bit errors in the bitmap, use space is going to show that there is more use space than there actually is. So if, let's say, we capture 90% of the bitmap file and 10% have errors, it's going to say that 90% is guaranteed that's there, but the 10% that was read with errors, it's still going to say it's in use. It may end up being zeros. So full disclosure, guys, I have not resolved this case yet. I don't even know if I'm going to be resolving this case, and there are a few reasons for that. Now, first of all, this is going to take unpredictable amount of time. I was able to get this device imaging up to 250 megabytes per second in some areas, but I found out that those areas consisted of nothing but zeros, and that's towards the end of the unit where it wasn't even used. I can provide this device to the client in working state like it is right now, and they can spend whatever time they want on this device and try and solve it, and we'll just charge the cost of repair. Now, from what I understand, Ace Labs tech support already logged in remotely to assist with the build of this device, and they couldn't get it to create a translator. So if they couldn't get it to create a translator, that tells me that most likely the chips were not fully connected. They had too many errors come up during the build, even though we had errors come up during the build. But as you could see, we could access data, we could see the partition, we could see how much space is in use, we could read the data. It was just super slow. So maybe the problem was really with connection at the very beginning. I really enjoyed working on this device. Looking forward to more Angelbird Cfast 2.0 cards. So if you got one that doesn't work, send it to me first. Don't send it somewhere else so that I can get it later. Send it here first. You'll get better chances of getting your data back. Guaranteed. Thank you for support. I'll see you in the next episode.